Now to move on to section 4.3, separable equations. Let's define what it is first. A separable differential equation is an equation that can be written in the form y prime is equal to a function of x times a function of a y. So let's talk about a little bit why they are called that. So again, it's anywhere where I can write y prime is equal to a function of x times a function of a y. So basically, what's really neat about these, if it's just a function of just x times a function of just y, what I can do, remember y prime is like saying dy dx. What I can do is move everything with a y over here, everything with the x over here, which would make it dy over the function of y equals f of x dx. Why is that helpful? Because then I can just do this on both sides. So what I want to do is move everything with y over here, take the antiderivative, and then after I do that, solve it for the y. Okay. This is going to use a lot of those tricks and strategies and everything we learned in chapter 3. So it's a good idea to have that down before starting this. So example number 1, find a general solution to the equation y prime equals x squared minus 4 times 3y plus 2. So once again, y prime equals x squared minus 4 times 3y plus 2. So again, this equation is separable because I can split it up and put everything with y over here and everything else over here. Had this have been 3xy, it wouldn't work because the x right here ruins everything. Okay, so a function with just x times a function with just y. So what I can do, remember y prime is like saying dy dx. So I can bring this y over here by dividing it, and then bring this dx over here by saying times it, right? So I end up with dy over 3y plus 2 equals x squared minus 4 dx. Again, just brought the y over here, the x over here. Once I have that, integrate both sides. On the left side over here, since I have 1 divided by some stuff, I know that's the natural log, right? But this is 3y, which means I would need a 3 up here, which I don't have, which means I've got to put 1/3 out front. So 1/3 natural log of 3y plus 2 equals, now do this side, x squared, add 1 to the power, then divide by that thing, right? So that's going to be x cubed over 3. For 4, we end up with just 4x. And then, of course, always do the plus c. Now, technically speaking, I should have put plus c over here too on this side. But if I have a constant over here and a constant over here, I could move that constant to the right side, which would still just make it a plus c, right? So you could just put plus c over here. So now I want to solve this for the y. So what I can do is I have 1/3 out here, so times it by 3, times both sides by 3. Gives me natural log absolute value 3y plus 2 equals 3 over 3 is just 1, so that's just x cubed. 3 times 4 is 12, so minus 12x. 3 times a constant is still just some c, right? So we can just leave it as plus c. Technically, you could put plus 3c, but again, you don't have to because a constant times a constant is still just a constant. So c is fine right here. So I'm wanting to solve this for the y. Y is inside of a natural log, and so think about how I solve logarithms, right? This is log base e, which means I want to raise both sides to the e, okay? E to the natural log is going to cancel out, leaving me with just 3y plus 2 equals. This side, I'm going to do e to the power of x cubed minus 12x plus c. I want to pause really quick because there's a notation thing I want to bring up, okay? Remember our powers. If I'm saying plus c, right? So e to a bunch of stuff plus c. Technically speaking, I could split it up, right? E to the x cubed minus 12x times e to the c because it's plus, right? Well, e to a constant is just a constant to a constant, which is a constant. So that's like multiplying that by c. So that's the notation we are going to do here, okay? If I have a plus c in the power, I can actually bring it out front and do times c. So that's what we are going to do. So now to solve this for the y, just subtract 2. 3y equals, I'm going to put negative 2 out front. Again, that's just a notation thing, because if you wrote minus 2 out here, it would look like the minus 2 went with the power, right? And it doesn't. So writing it out front is fine. But also, had you written it out here, that's okay too. I know what you mean. I'm just going to put it out here so that it's clear. Then lastly, I'm solving this for a y. So divide it by 3. It's going to give me y equals negative 2/3 plus a constant divided by 3 is still a constant. So I can just leave that as c, e to the x cubed minus 12x. So this is another one of those things where looking at it, it looks like it was hard. But truly, this is just using skills you already have to solve it for the y. Okay. But of course, if it doesn't make sense, then let me know. I will be happy to help you out. Example number 2, we're going to do the same thing for y prime equals 2xy plus 3y minus 4x minus 6. Y prime equals 2xy plus 3y minus 4x minus 6. At first glance, this one doesn't look like it would work because I have xy and y and an x. Like I don't have a function of just x times a function of just of y, right? Which is what I want. But I can factor this to where it does look like that. So for example, to show you here, what's a factor of both of these first two terms have, right? Well, both of these have a factor of y. So from my first two terms, let's factor out a y, which would leave me with 2x plus 3. What about over here? Both of these have a factor of negative 2. So this is going to be negative 2 times. That would also leave me with 2x plus 3. Well, now both of those have a factor of 2x plus 3. So factor out 2x plus 3. And I'm left with y minus 2. Now it looks like how I want it, because now I can bring the y's over here and make it dy over y minus 2 equals 2x plus 3 dx. So now antiderivative of both sides. This is the natural log, and since it's just one y, I can just leave it as natural log, absolute value y minus 2. Again, I should put plus c, but I don't have to because then I would move it to the right side and put it with that one. So I don't have to. 2x, the antiderivative of that is x squared. For 3, it's just 3x, and then plus c. Again, I'm solving this for the y, so I need to have e raised to both sides. So that's going to leave me with just y minus 2 here equals e to the power of x squared plus 3x plus c. But remember, like I said, e to the c is a constant, so I can actually put that plus c or times c out front. Now to solve this for the y, just add 2 on both sides, and you get y equals 2 plus c e to the x squared plus 3x. And that is it. Once again, if it doesn't make sense, let me know. Next example gives us a point, and so now I'm going to have to actually solve it for the c. But this one is y prime equals 2x plus 3 times y squared minus 4, where y of 0 is equal to negative 3. y prime 2x plus 3 y squared minus 4, where y of 0 is negative 3. Okay, so the same thing. I have a function of x times a function for the y. So I can bring my y's over here. So dy over y squared minus 4. Remember, that's like saying y minus 2, y plus 2. I could factor it. Equals, that's going to be just 2x plus 3 dx. So now I'm going to take the antiderivative of this. What makes it complicated is the denominator over here, right? It's not harder, just a little bit more work. Since I have two factors over here, I can use partial fraction decomposition, which is something we learned in chapter 3, right? So remember what this means is that I'm going to have something over the y minus 2 plus something over the y plus 2. And that should add up to give me a 1 on top. So for the a, I need to times it by y plus 2. That gives me ay plus 2a. For the b, I need to do y minus 2. So plus by minus 2b has to be equal to 1. So the y's, ay plus by, there's no y's over here. So a plus b has to be equal to 0. And then 2a minus 2b has to be equal to the 1. So this means a is equal to negative b, which I could plug in there. 2 times negative b minus 2b equals 1. Negative 2b minus 2b is negative 4b. So b is equal to negative 1/4, which means a is equal to positive 1/4. So this becomes the integral of 1/4 over y minus 2 plus the integral of negative 1/4, so I'll do minus 1/4 over y plus 2 dy equals 2x plus 3 dx, the integral of that. So this is just the natural log, and it's just a 1, so that's helpful. So it's just 1/4, because of the 1/4 up here, ln absolute value of y minus 2, minus, again, 1/4, ln absolute value y plus 2 equals antiderivative of 2x is x squared, antiderivative of 3 is 3x, and then plus c. This looks horrendous. We want to try to rewrite this as best as we can. Since there's a 1/4, I can times everything by 4 and get rid of that, right? So multiplying this by 4 gives me just natural log absolute value y minus 2. Minus, again, times 4 makes it just natural log y plus 2. Timesing this by 4, though, you get 4x squared plus 12x. 4 times c is still just some c, so we can just leave it as c. If you want to write 4c, that's completely fine. It doesn't matter, but you could just leave it as c, and that's fine. Still looks gross, so let's try to figure out what I can do with this side. Since I'm doing a log minus a log, remember I have a rule that when I'm subtracting them, I can divide it. So this is the natural log absolute value, y minus 2 over y plus 2 equals 4x squared plus 12x plus c. Now I just have the natural log on this side, so I can do what I have done on the last few. Since I have a natural log, I want to use e. So y minus 2 over y plus 2 equals e raised to all of this stuff, which will give me c e to the 4x squared plus 12x. Again, because e to the c is just a constant, so I can just bring my c out here. Let's continue solving this for y. I don't want a denominator here, so let's times it by y plus 2 on both sides to get rid of it. Cancel out here, times y plus 2. This is going to be y minus 2 equals, times it by y first, gives me cy e to the 4x squared plus 12x, plus, and then times it by 2. 2c, now I've got to leave it 2c, because even though, yes, 2 times c would still be a c, there's another c over here, and they've got to match, right? So leave it now as 2c because there's more than one c. So leave it as 2c. E to the 4x squared plus 12x. Okay, so we're solving this for the y, which means I want to move every y to one side and everything else to the right side. I have a y here, which means I want to move it over there, right? I want to move this term over there because there's a y. The minus 2 right here doesn't have a y, so I want to move that over there. So what I end up with is y minus cy e to the 4x squared plus 12x equals, that becomes positive 2. 2 plus 2c e to the 4x squared plus 12x. Both of these have a y, so factor out y. It gives me 1 minus c e to the 4x squared plus 12x. And then I can just divide by this guy. So y equals 2 plus 2c e to the 4x squared plus 12x over 1 minus c e to the 4x squared plus 12x. This would be all fine and good, and I could just stop right here, but they gave us a point. They gave us a point, which means I need to solve for the c. So now I need to solve this for c using that point. We're going to plug 0 in for x, negative 3 in there for the y, and we get negative 3 equals, on top, 2 plus 2c times, if I plug a 0 in here, I'm going to get 0 plus 0, and e to the 0 is just a 1. So it's 2c times 1, so I can just leave it as 2c. Over 1 minus the same thing here, this becomes 0 on top, which gives me a 1. C times 1 is just c. Times both sides by 1 minus c, so I can solve it for c. I end up with negative 3 plus 3c equals 2 plus 2c. Subtract 2c to bring it over here. Add 3 to bring it over here. And you get 1c is equal to 5. Therefore, what I get for y equals 2 plus 2 times c. 2 times 5 is 10. So 10e to the 4x squared plus 12x over 1 minus c, which is 5, e to the 4x squared plus 12x. If any of that doesn't make sense, let me know. I will be happy to help out. Okay, last example, example number 4. Gonna work kind of the same way. Example number 4 is 6y prime equals 2x plus 1, y squared minus 2y minus 8, such that y of 0 equals negative 3. All right, same thing here. I want to move every y over here. The 6, it doesn't really matter which side I put it on, but think about it though. If I wanted to move 6 over here, I would have to divide by 6, which would give me 1/6 times all this stuff, which is just going to look really bad, right? So it doesn't matter though. It could stay here or move it over there. It doesn't really matter. I'm going to leave it over here. So 6 over, I'm going to move my y's over, right? So if I factored this, the factors of negative 8, whose sum is equal to negative 2, it's going to be negative 4 and positive 2. dy equals 2x plus 1 dx. So then do the same thing, integrate both sides. This one again, I'm going to need to split it up, right? Something over y minus 4 plus something over y plus 2 is going to be 6 over that. Had you have moved 6 over here, it would be a 1 here, but again, that doesn't matter. A I've got to do times y plus 2, so ay plus 2a. B times y minus 4, so that's going to be plus by minus 4b has to be equal to 6. Ay plus by, notice there's no y terms over here, so a plus b is equal to 0. And that leaves 2a minus 4b to be equal to 6. So subtract b, a equals negative b, so that's going to be negative 2b minus 4b equals 6. That means negative 6b equals 6, so b is equal to negative 1, and therefore a is equal to positive 1. So this becomes the integral of 1 over y minus 4 dy plus the integral of negative 1, so I can do minus 1 over y plus 2 dy equals the integral of 2x plus 1 dx. These are not very bad at all. This is just natural log absolute value y minus 4 minus natural log absolute value y plus 2 equals 2x. If I go backwards, gives me x squared. 1 becomes just an x, and then plus c. And then now we want to solve this for y. Just like on our last one, since I am subtracting these, I can divide them. Which means now I can do the e thing, right? So raise it to e gives me y minus 4 over y plus 2 equals, raising e to all that. Once again, e to the c is still just a c, so c e to the x squared plus x. Multiply both sides by y plus 2 so that I don't have a denominator. Gives me y minus 4 equals, this times y gives me cy e to the x squared plus x plus 2c e to the x squared plus x. Move all the y terms to one side. Gives me y minus, I would want to move this term over there because it has a y. Cy e to the x squared plus x. Add 4 over here, gives me 4 plus 2c e to the x squared plus x. Both of those have a y, so we can factor out y, which leaves me with 1 minus c e x squared plus x equals 4 plus 2c e x squared plus x. Divide by all of this stuff will give me y, so y equals 4 plus 2c e to x squared plus x over 1 minus c e to x squared plus x. Which would be nice if I could just stop there, right? But they give me a point. Is it y0 equals negative 3? Yeah, the same point. There we go. So plug 0 in for x, negative 3 in for y, so that I could solve for c. So negative 3 has to be equal to 4 plus 2c. If I plugged 0 in here, 0 in there, that would give me just 1. So I can stop at just 2c. Same thing over here, 0, 0 gives me a 1, so it's just 1 minus c. Multiply both of these by 1 minus c. Negative 3 plus 3c equals 4 plus 2c. Subtract 2c and add 3 to both sides. Gives you 1c equal to 7. So that gives me y equals 4 plus 2c, 2 times 7 is 14, e to the x squared plus x, over 1 minus c, which is 7, e to the x squared plus x. So I know the notation of all of this, and the work makes it seem really hard. So if it doesn't make sense or if something isn't clear, let me know and I will happily help.